Centerprise Best Practices webinar series. Centerprise was developed especially for the complex data integration needs of today's business environment. Today we will cover the important complex data integration capabilities in Centerprise, which includes data sources, including databases and hierarchical files, the Centerprise object model, hierarchical transformations, and common scenarios. Please be sure to type in your questions, and at the end of the webinar we'll answer as many as time allows for. We'll capture all questions and answer them in a written Q&A document that we'll post on our blog and our support site. Now I'll turn you over to our technical specialist, Mike Oakland, who will be conducting today's presentation. Mike?
Thank you, Brittany. Hello, my name is Mike O'Quinn. I'll be conducting today's webinar. I'm also in charge of support, so if you've ever submitted any question to support or sent an email or had any questions on our forums, you've probably had some interaction with me. You might have heard my voice on previous videos, such as our help videos, which you can find on our website, and previous webinars, since I believe this is one of the fourth or fifth in this series here. So this one will kind of follow the same model if you've been following along with previous webinars. A little bit about Centerprise. This is our flagship product, and it is an ETL tool for moving data from point A to point B. In this demonstration, we'll be talking about the type of data that's going to move and specifically how to deal with more complex objects. But Centerprise is typically known for usability, scalability, and connectivity. Usability because business users as well as developers can use this tool by way of an intuitive drag-and-drop interface. It's a code-free development, so you don't have to write a single lick of code. You can see what you're doing as you're doing it with our single-click data preview, which is very popular in the product. It's a very scalable product because of the high-performance parallel processing engine. If you need more power, just throw in another Centerprise server and you've doubled your throughput. With 100% .NET code based, I guess I say that's the framework that it's based on. It can operate in batch, change, or real-time mode, so it doesn't matter what the volume type is, whether it's millions of records at a time or a single transactions at a time, Centerprise can handle it. And it can connect to all major transactional and data warehouse databases, flat files such as fixed length delimited, hierarchical files, which is the subject of today's topic, XML, EDI, JSON, etc., web services including SOAP and REST web services, and cloud-based applications including Salesforce and Microsoft Dynamics, QuickBooks, etc. So today's complex data integration issues, B2B data exchange has become a complex process involving a variety of different formats and sources, and these suck up large IT resources that are dedicated to transforming, validating, and cleansing this data. And this is true for not just hierarchical data, but flat data as well, but it becomes even more so when you're talking about hierarchical data just because of the complexity in dealing with these type of data structures. They're expensive, time-consuming, and they impede business ability to grow and be agile. So Centerprise can help because it overcomes these challenges by supporting straightaway XML, EDI, and other hierarchical formats within the tool natively. Business users as well as developers can use this tool collaboratively even, and it enables organizations to free up IT resources to focus on other important areas of the business, and you can maintain this kind of module or machine in dealing with this data with a much smaller set of resources. So how does Centerprise work with hierarchical data? It has the same tool set available as we're working with flat structures. So there's no need to, like in other ETL tools, to run like some sort of pre-processor in order to process, let's say, an XML message. You have to run a script in order to extract data from it, and then you can kind of get it into the hands of the kind of drag and drop world. No, not in Centerprise. You can do so all in the same screen and do so as intuitively as you would with a flat structure. We also have Centerprise has special components and modes that are created specifically for tree structures, and many hierarchical data formats are supported straight away right out of the box. Okay, so what are those hierarchical formats that are supported? Those are databases, hierarchical files, and web services. So they basically fall into one of these three categories. Of course, typically when you're doing one of these transformations or data flows, you're going to have some sort of interim hierarchical form, and that's totally okay as well. But just what we're talking about here is being able to connect and read and consume a hierarchical object right straight away, right out of the box. So first off, let's take a look at hierarchical files and which files are supported in Centerprise, and those would be COBOL, EDI, XML, reports, and PDF files, delimited and fixed-length hierarchical files. So at this point, I kind of take a look at Centerprise, the actual tool itself. And on your screen now, you should be seeing Centerprise Data Integrator. This is the tool in question, ETL tool. It's actually one half of it. The first half is the part, the GUI, and this is used to the designer and used to create what we call data flows. So this has an IDE, which in case for those of you not familiar with Centerprise, and we have certain several windows that are available to you, including this data preview here at the bottom. You can move windows around. I can place this on the left side if I wanted. I'm going to leave it on the right. I like my project on the right side. But the main window being this document window. And this document window is what we call the data flow window or the workflow window. It depends on what document you're talking about, but the main document being the data flow. So the way it works is that you have this toolbox here on the left side, and then you drag and drop items from the left to right, and then you map in such a manner. So for example, let's take an example of a typical flat structure. So you might have something like an Excel workbook source. And if I expand it here, you'll see that I have a tree. It doesn't look very much like a tree because it's just a stump at this point. But once we configure it, we will get a tree. So I'm just going to point to my file here. Find it. Demos, and I'm going to use this loans file here. Here you can see a preview of what that data looks like from Windows. And if I click OK and OK, you can see that I now have a tree structure. I know hopefully a lot of you are very familiar with this already, but bear with me. And then we have the structure here. Of course, it's not very tree-like. It kind of looks like a post or a pole with our elements and mapping ports here on the right side. So the way you would typically work is you go into the toolbox, you go into your transformation sections, and let's say you have to sort the data first. You connect that, and then after you've sorted it, you need to filter it. And then after you've filtered it, you need to then write it to some database target or some file target, depending on what your business needs are. And then now you have your complete flow. So this is for the flat, dealing with flat data structures. It's pretty easy, and a lot of competing ETL tools will do kind of something very similar. What's kind of very unique to Centerprise, though, is how it deals with hierarchical data. So let's say, for example, we're talking about an XML file. So where is our XML file? Let's take a look at this file. So here's an XML file, which is notably not flat, in which case we have root here at the top, and then we have repeating payment nodes. Underneath these payment nodes, we have some other elements, and then we have another subnode which has its own elements, this members node. So in Centerprise, we'll go ahead and display that such like so. So again, we just go to the toolbox to process XML files, and we'll go drag and drop XML source, and we have again our box. In this case, it's empty, no tree inside. And once we've configured it, in this case, we're going to ask for the file as well as the schema location for that file. And once we've set up these things, we now have our tree here, and you can see this much more tree-like. We have our objects indented, and these deal things are elements or the fields. And then at what point we can preview the data, and now we see the instead of a flat data preview as we would in our other example. Where'd it go? So here's what a data preview looks like in the flat world. You can see it's just a table. In our XML example, if we do a preview, we see that it's actually also hierarchical and representative of that data structure we saw a few minutes ago. So this is the XML file, and we'll get into how you can deal with XML files in a little bit, but kind of continue our tour of supported hierarchical file formats. On the project here on the right, you can see I have a section here called data sources, in which case I have a flow containing the different file types that you can read here. So we got XML, EDI. Let's take a look at that. What that looks like. Here's one where it's we have an EDI file. And that's, for those of you who don't know what EDI is, it stands for Electronic Data Interchange. It is just a simple, delimited file, very concise file for retail and healthcare industries and how they typically communicate. Centerprise is able to handle these type of files no problem, as well as COBOL files. Here's an example of a representation of a COBOL file in Centerprise, and then finally as report sources. So here's a report source. The actual file that we're dealing with here might look like this. Here's the PDF file, and here you can see that a clear hierarchy, very complicated hierarchy with different sections, with repeating information being the employee information, and then some other repeating, indented information there. So I won't go too far into it, but we'll kind of see how Centerprise can, how it came to that structure here. Here's the RMD file, and this is how we were able to define the zones for that file and the various hierarchies for that. So once we've defined the zones and the hierarchies of that file, we can then use that straight away as a report model source, preview just like the XML file, and then we have the mapping ports that we're able to use to map the individual data elements here. So those are the file sources supported. Continuing on in our demonstration, we also support database hierarchies. So what do you mean by database hierarchies? Well, in typical relational database, you'll have implicit hierarchies, such as, let's say, an order table and a line item table. You'll have a one-to-many relationship with that. So the way to do so in Centerprise and deal with those hierarchies in Centerprise is to create what we call a data model. So we have two types of data models. We have the built-in data model, and we have the kind of the manual data model. So they're both very viable and good ways to deal with this type of data situations in Centerprise. The first one, the data model, is easy to create, and the joins happen in database, and you can't do anything but join in database. It'll just construct the various queries needed and do the joins in database as needed. Then you have the new way to create a data model, which is basically to create another flow with a bunch of joins with those tables. It's a little bit more work than the original data model, but it's much more flexible, and I'll show you what we mean by that in the tool. So let's go back to the tool, and let's take a look at the section here, which I've in the folder called Data Model. And here I have an order flow using Data Model. So in this case, you can see that I have a structure, a hierarchical structure here, starting with my order entity and related customer, order item, and product tables. You can see these are my database tables in this demo database here. So how did we get this structure? Well, we defined a data model. So let's go ahead and edit data model, and this will show us the other object that we created. And basically, we just dragged and dropped these table entities and defined the relationship. Now, many times by foreign key, these relationships are automatically defined, but this is very powerful enough so even if you don't have an implicit or an explicit foreign key relationship, you can define your own relationships between tables and use this data model in the data flow. So once I have this, I can again preview. I can start mapping from these objects, and I can start transforming the data from this hierarchy, maybe even move it into another hierarchy, or take separate pieces from the individual levels, which we'll get into in a little bit. So this is one method of creating a data model. You can do so very quickly and easily in Centerprise. The second method is to create your own using what we call a subflow. So in this case, I've created a subflow, and it should look very familiar to you. It should look very familiar to the data model. In this case, I have the order, and I have an out because it's kind of an extra node here, but it need not be there. And then I have the order item, product, and customer tables, all available to me to map from. So let's take a look at what this one looks like. So in this one, all it is just another flow. We created the model based on joins between tables. So here we're using a tree join, which again we'll get into in a few minutes. But we're just joining two tables at a time. and then here's our third table, and so on and so forth. And finally, we have our hierarchical output, which we're able to use as our output interface to the outside world, to whoever's using this subflow or data model. And we can also map from this particular data source. So that covers the how Centerprise can deal with in database tables, particularly reading from them. When we're talking about writing to a hierarchy, for that will be a slightly different scenario, and we'll get to that in kind of towards the end of the webinar. So going back to our presentation, the third item as far as being able to connect to hierarchical and consume structures deal with web services. So the web services are your the inputs and output payloads are almost always hierarchical, unless you're dealing with a very simple kind of get on a very simple resource. You're probably going to be sending it XML and receiving back or XML or JSON, but it's going to be a hierarchical structure. Web services are a gateway, Centerprise's gateway for countless consumer and enterprise APIs, from Twitter to Google to Yahoo, and even intra-business APIs, whether it be SOAP or RESTful web services. You can consume them via Centerprise. We'll take a look at that, what those look like in the product. So take a look here at the web services section. So here in this one we're dealing with a RESTful web service, in which case we have the input being the URL, basically the URL parameters. Here's our data source, so what we're feeding it. We got in the name column Mike and Jay, and we're giving it the ID 1, 2, 3, and 4, 5, 6. And then we get back information about the response, and as well as the composite type. So again, another hierarchical data format. If we preview the data, in this case we get our tree again, including the output node and the response node, which gives us information about the service call, and then the actual object, which gives us the hierarchical structure. Now in this case it's not very hierarchical, it's just a Boolean and a string value. The first node being the 1, 2, 3 value we fed it, and the second one being the 4, 5, 6 value we fed it. But just know that you can use both SOAP and REST to connect to various different types of web services. Once you've set up the properties, the mapping to and from connecting to web services is exactly the same as database or flat files. So that is the web service capabilities of Centerprise. So with that being said, let's take a look at, let's discuss what we've been seeing on the screen, and that is the Centerprise object model. So when we were taking a look at the Excel file, and I mentioned that poll, that was still we were still dealing with the Centerprise object model. It was just a simple object. When we're talking about complex objects, you're talking about more of a tree. And what you see on screen is the layout tree, and that's representative of behind the scenes what we call referenced objects and collection objects and elements. These are the three items that appear on the screen, and depending on what those are, you have different rules and how to deal with them. So a lot of this webinar will kind of walk you through on how to deal with them within the tool without, hopefully save you from getting stuck, and hopefully you'll learn a few things from this webinar. Also, the data preview and how the web object model affects the data preview. Also, we'll be discussing the concept of anchors and cardinality rules. So let's go back to the product, and we can discuss all four of those things. So let's take a look at the one of the previous flows that we're looking at. This one. Now let's zoom in here to 200%, so we can get a better view here. So this is the layout tree that we were talking about. The layout tree has different objects in this tree, and you'll notice that the first one is this little cube here, and this is the root object, and basically it represents the object of the box, so it's synonymous with the box. So if I change the order to, let's say, orders, you'll see the root of the tree also change to orders. So this is important when you're dealing with, let's say, things like expressions, in which case you need to reference items further down in the tree. It will be depending on whatever the name of this box is or name of the root of the tree. It will be orders.order item.quantities, for example. So that is how the tree basically affects the structure when you're dealing with other transformations in Centerprise. The next object you'll see here is this little, you'll see two types of boxes here. You'll see the same cube but with this little shortcut icon, and then you'll see a collection of 4 cubes kind of bundled together. So what this means is that this is a one-to-one relationship to the node above it. So in this case we have, for every order, we only have one out node, but for every order we have multiple order items and multiple customer nodes. Here underneath order item we have a product node, which means again for every order item we have only one related product node. So this is very important when you're talking about cardinality and what you can map from. So it also brings us to the, and then, by the way, before I gloss over it, these little yellow tags are the elements. So even though the structure, let's say an XML structure, might not differentiate between an element and an object, these are very different in Centerprise because the object is basically, you can think of these as their own little data sets. So much like if you were to join together multiple data sets in the flat world, multiple data sets are implicitly joined in this tree here. So let's zoom out a little bit, and that brings us to the concept of what an anchor is. So let's take a look and preview this data model here. And here you can see we have our element here, and in the preview you'll see we have the object path. So this object path will tell you at what level of the tree you're at in. So here you see that we're at order out and all of the elements under order out. So this is the object, and then to the right here horizontally we have the elements, and these are represented by these yellow tags here. If we expand the data preview, you'll see order item, which is the object, and again we have the little yellow tags representative of this object to the right of the path here, and we can just keep going on and on and on and showing the tree here. So as far as reading when we're previewing the data, and by the way I have preview here set to 0. This is a kind of a gotcha when you're dealing with hierarchical data. Many times if you're doing like such a table such as joining information such as this, if I were to preview the first 50, I might only get the first 50 orders but not get the related customer. So when you're dealing with some hierarchical structure such as this, many times you might want to set it to 0 to be able to see everything. Be wary though when you do that, because if you do that and you're dealing with a very high volume, you might actually bring down the application if you're talking about millions and millions of records. So just be wary be careful when you set this to 0. It's very powerful, but with great power becomes great responsibility. Thank you, Spider-Man. So going back to this thing now, so when we're previewing data, we see that we have our data structure here, but as far as what is going to drive the rest of the data flow, what would that be? So for example, let's go into our transformation section and let's take a pass-through. Pass-through transformation doesn't do anything, and I'll be using this a lot in this demonstration. So let's go ahead and hook this up to order. Oops. Right? And let's just map it from out to pass-through here, and let's take a preview of it. So preview is going to show me that I have 1,000 records, and this is what the data set looks like. So I can actually preview, do a quick profile, and I can see the count without having to see the. So here you see I have a total of 1,000 records. Let's undo, or let's do another data preview, pass through, and now let's take the item at. Let's just remove all elements here. Actually, let's leave it, and let's take order item for example. So this is another section, and we're only dealing with the section of order item. We're not taking anything from the order table. And let's go ahead and do a quick profile on that one. So on the inner node here, we see that we have only 988 records, which means that we have some orders without appropriate line items. Probably a business, probably a data entry snafu, why we're missing those. But you would think that you would have more line items than orders, but in this case we have less. Nevertheless, the important part is that these two data sets have a different what we call cardinality. Cardinality just means the number of items in a set. And because we have these two different items, we have different rules for how we can process them. So for example, I cannot do something like this. I cannot do a preview, a pass-through, send this on from here, and then add elements from here. This is a no-no because here I have 1,000 records, here I have 988 records. I don't know which of the 988 to keep in this data set here. So if I try and preview here, you will get this error, pass through 3 depends on pass through 1 and 2, blah, blah, blah. It can only depend on one transformation. Now this applies to the flat world when dealing with flat structures, but it's especially true when dealing with hierarchical structures. So for example, let's say that I am dealing with the order item here. So now here I'm just dealing with order, so you can see that I have 1,000 records. Let's say that I take the order item ID, or more appropriate, this order item ID from the subnode here. Doing so, I now have mapped items from the subnode as well as the parent node, and if I do so, I now have 988 records. I no longer have 1,000 records. Why? And this is an important concept when dealing with hierarchical data in Centerprise, is that I've now changed my anchor point. So the anchor, because we don't know which one you're talking about. Are you talking about this data set, or are you talking about this data set? So the way Centerprise gets around it is that it'll find the deepest leaf or the deepest object in the tree in which you're mapping from. So in this case, the deepest node is order item, and so this will be the driver, and this will be for each for the n number of records that we're extracting from this data set. And that is why, just by including that single field, we will get that will change the data set from 1,000, from this being the driver to this being the driver. Okay, so let's say now that we want to include another field, and we want to include from a sibling node of customer. So doing so, we'll just go ahead and map it, and now we will get that same error. In this case, it won't tell. It is the same error. It's slightly different, but it's basically saying it's inconsistent with other source paths. Anytime you see this cardinality, it means that you're trying to map two different data sets into a single data set. So here we know that we have 988 from order items here, but we don't actually know how many customers we have here. So we don't know from which index to extract that information from. So just keep that in mind when dealing with hierarchical data, that you'll have to pay attention to from which data set you're mapping from. But Centerprise has components to deal with that, and I'll get into it, and I'll circle back to this example. But just for now, note that when dealing with hierarchical structures, you have to deal with concept of anchors, meaning that which one's driving it, and cardinality, which things you can map into a particular data set. Okay, so going back to the demonstration here. Applicable transformations that you can work with in Centerprise when dealing with this type of data. There's two types of transformations. There's the transformations that support hierarchies in the layouts themselves. So every transformation has a layout. Some transformations support a hierarchical layout. And then there's other transformations that maybe don't support a hierarchical layout, but they help you in modifying or creating tree structures. So this list includes the filter, the sort, the route, the union, tree join, and the pass-through, which you've already seen. So taking a look at those in the product, let's take a look at what some of these transformations here. And you can see that I've already drag and dropped a lot of them from the tool here. So again, this should look very familiar. It's the XML file that we started off with. The filter, I just drag and drop. You can see that it has the same structure, and they all can support this structure here. You can see they all have this subnode in the structure. Even the union can have that as well. So any of these transformations, if you look at the properties, you'll find this panel here on the left, and this panel is the hierarchical panel, in which case you can hide it by clicking this cube here. You can also add to the layout by clicking on, so this is probably something that's often overlooked. You can you can create hierarchical structures within these transformations by clicking on either adding a reference object, again, meaning a one-to-one relationship, or the collection object, meaning that you have a one-to-many relationship. So all of these are supported in these transformations, and they behave the same way. If I add a filter to this, I'm actually filtering records at the top level. Same thing if I'm sorting records at the top level. So I'm taking this record and sticking it there. And unioning, same thing. So this is all one record, and I'm performing these operations all on that same single record. So those are the available transformations. I won't get into what these transformations do, because we have other webinars and other references for telling you how to deal with routes, unions, sorting, and all that up on our website and YouTube channel. Very useful videos. You can see exactly how they work, but outside of the scope of this demonstration. So the other transformations that we'll be discussing are the supplemental transformations. So these are the transformations which are kind of the superstars when dealing with hierarchical data. And these include the flower transformation, aggregate transformation, scope transformations, and text processors. So starting with the flower transformation, this is not a typo. This stands for let, where, order by, and return. And it basically allows for querying a tree for a specific node or nodes. And this one must be scoped. You cannot use it without a scope transformation, and we'll talk about what a scope transformation is. But first off, let's start off on what is the flower transformation. So this is without a doubt one of the most useful tools when dealing with hierarchical data, because when you're dealing with hierarchical data, there's a lot of ambiguity of what you want out of a tree. So this helps solve what you want, that question of what you want. Okay, so let's go back to our data model here, and let's take an example here where we want the cardinality path. We want to get rid of this error now. So let's say that we know that there's only one, that we will only want the first customer. We know that there could be multiple ones, but we're not concerned with them. We just want the very first one. So how do I tell this subsequent transformation that, you know what, don't give me this error, because I know that I only want the one at the index of 0 of this object here. How do I get that? So what you can do is look for the very handy-dandy flower transformation, drag it onto the diagram, and now I'm going to name it get customer. Actually, let's move it along here so that we are kind of only dealing with a few objects here. So let's remove all elements, and I'm going to copy the layout here. And by the way, this is very useful in the tool. You can, anytime you see a layout in a tree, and especially when you're dealing with hierarchical layouts, you can say copy layout, and then if the transformation or the box supports a hierarchical layout, you can actually paste it, in which case you've automatically created that layout without having to go through and type it in. So I'm just going to go ahead and map from here to there. And now I want to create another pass-through, in which case I'm just going to take the keys to kind of just simplify this example. All right, so we got order ID, we got order item ID, and now I want my customer ID as my third one, right? So again, the preview, I get the error, so I'm going to have to use this flower transformation. Oops. And then what we're going to do is say get customer, and I'm going to send customer ID here. Actually, I'm going to take the entire customer node, and I'm just going to map customer ID to customer ID. So at this point, if I try and preview, it's going to say does not have a scope map. So, and it says pass-through depends on, you can only depend on one transformation because I have not scoped it. So first of all, let's set this up and pick out which item I want. I want the first item at the first index here. So I want the first node in that collection. So now I've kind of taken that collection and I've kind of flattened it. So at this point I need to attach it to the tree. So now this becomes a sibling node that I need to say it's kind of like I just created a new node in the tree and I'm going to map to it. So to do that, I need to attach it to a certain point in the tree. So I'm going to attach it to this top node here. And to do that, hold down the Alt key, in which case you'll see this little turquoise line here. And then let go, and you'll see this dark kind of greenish turquoise line. And it's connected at the object level. So from this object to this object, I've made a connection. So you can think of this as being another node in the tree at this level. So now that I have that, I can preview, and now it works okay. I have my order ID, order item ID, and my customer ID. So I was able to dip further into the tree and pull out a specific node in this tree. So this becomes very handy when, let's say, dealing with an EDI type file. So let's take a look at our EDI source here. And let's say that here I have a date time, and I need to, so the way EDI files work is that since they're so concise, you'll have a collection of elements, and collection in the segment at the 0th index means one thing, and the collection at the other index means something completely different. So I might take my flower transformation and say get date type 1, in which case I'm going to take DTM01 and DTM02, copy and paste. And again, map the same elements in there. And the only thing that's going to be different is I'm going to say, I'm going to make use of the filter in here and say only when DTM is equal to 002 do I want to take the first item. I can even sort if I want to, and do all kinds of different transformations with the flower transformations. Now that I have this, I am able to extract the individual index out of this collection. So when dealing with very bushy trees like this, or even creating bushy trees like this, the flower transformation will be your very best friend. So going back to the other example, so in this case, this is just a single example of a scope transformation. We have, by far, we have basically anything in the toolbox you can also use in this matter. So let's say that you have this, this collection here. And you said that you want the very first customer ID. Well, what if you want the customer ID to be sorted, so based on some logic, right? So what we can do is, let's say we want to sort this information before we start mapping it. So we want to sort this collection. We don't want to sort at the top level, right? So we can bring the sort transformation here. Here we go. And if we were to connect, even though it supports a hierarchy, if we were to sort at the top level here, we would be sorting the entire record. We only want to sort the subnodes here. So to do so, we can take this collection and then sort it. So let's take this and scope it. Or actually, for a better example, let's get rid of the sort here, and let's say we want to sort it from here to there. So here's from here, from the source to the intermediate transformation. We want to sort this data set. So for that, we're going to go sort, connect it to here, unhook all the maps here, connect it to here, connect this one to there, and again, use the scope transformation to define with what it's respect to. So now I was able to sort this transformation within the tree. So I've done an inter-tree sort, I should say intra-tree sort. So this is just the sort transformation. All of the transformations are available to behave in this manner. So this is something unique to Centerprise that you will not find in any other tool. It's its ability to perform the normal flat transformations all within a tree. So you don't have to create multiple maps where you're taking this node of the tree and then that node and then that node and then creating different flows and then operating on them. You are able to work right away within those transformations within the tree to get to your target. So you can do so all in one diagram. Okay, so that is the scope transformation. There's another particular very useful information besides the sort, which is the aggregate transformation. So it kind of gives new life to the aggregate transformation. So let's say that I want to count the number of orders in my order table here, right? So let's say I have another, let's say just a simple structure here. I'm just going to use a pass-through again, and again take the top level order. And I want to have another field here called number of items. Well, for that I need to count the number of order items underneath it, and for that we're going to use an aggregate transformation. I'm just going to take the order item ID. Again, this is a scope transformation because I need to dip into further in the tree, and then just connect it like so. Say this is a count, not a sum. And now if I preview, I've got to hook it up to the other one actually. But the idea is that I can preview the number of items, and it'll give me that number of items. I'm able to dip into the tree and use the aggregate. So this is aggregate is a very common transformation when dealing with hierarchical data. And by the way, we're getting close to about 20 minutes off from the end of this webinar. So just to remind you to type in your questions. We'll have somebody fielding them and clarifying with you as you go along. And in about 5-10 minutes to go, I'll start answering those questions. Okay, so that is that's the concept of a scope transformation. And when you're anytime dealing with hierarchical data, you'll be dealing with scope transformation quite a bit. Okay, so moving on. Okay, we talked about scope, we talked about aggregate, and the final thing is the text parsers. Text parsers are when data is contained within another structure. So what happens is you have two formats at one time. Let's say you have an XML file, and within that XML file you have delimited data, or very common, you have a database table, and within that database table you have XML data. So that's actually how we deal with a lot of our structures internally. So let's go ahead and take a look at that. So in this case, I have a database table. Let's take a look at what that table looks like. It's called the messages table. And in this messages table, I have some information: the primary key, when this message was received, who it was received by, and what the message it is. Here you can see it's an end text type. If we preview the data, you can see the data: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The bunch of different dates, a bunch of user IDs, and if you look at the actual message itself, you'll see that we have XML. So whenever I encounter data like this, I can go into my toolbox and make use of my parser, text parser transformations. So we have its own section here, and we support delimited data for parsing, fixed length parsing, EDI parsing, and XML parsing, which we'll show in this example. So for this, we're going to go ahead and take the XML parser, not the builder, and map the message text. So let's go ahead and map the message text here to text. And for this, we're going to have to point it to the schema. And it's the payment data XSD here. Note that we have the isJSON flag here. So if you are in possession of JSON data, you can actually use the XML parser to also parse JSON data. So now that I have my pointed to the schema, again, you see this hierarchical structure again, in which case I have my collection of payments and referenced member nodes. So I can go ahead and preview the data, and again I see my preview, and it's the exact same preview that we saw in the beginning of this demonstration. I can even take this structure and I can serialize it, or take an XML structure and go the other way. I can build XML from that. So this is very useful. Let's say I have a free-formed web service, or I need to write into a table where I'm just storing XML. Basically, I'm just going the other way now. I'm going to take the XML structure. So again, point it to my payment data XSD. I'm going to build one record per output, and I'm going to expand here and just map from root to root. And now I have my, take our trusty pass-through here, and take the text output node, and I have inner XML is not a member root. Now I got to remove this one. Which one is that one? Find here. Okay, I got to remove one of these. It's not liking this inner XML. But the point being is that I can take this XML and then just remove it from the transformation. So, so now that I have the XML, I can actually deposit this into a database table, a fixed length file, web service, what have you. Again, this behaves the same way with text processors, XML, web services, and whatnot. So one thing you'll notice here, though, is that I have this inner XML, and this is a special node that's available to you for you to use with this file format. So, for example, let's take a preview here. Preview. Okay, what is it? Okay, let's go back to another example here. So we got the NITF sample. That NITF is an example of what we're talking about. So this stands for the National Institute of, basically it's a News International Text Format, something like that. So, and then we have a structure here, and the structure has a lot of good stuff in it. You have your head, your metadata, your body, your published data. So this is information that's useful to me when I'm extracting data from it. And then we have this guy. So this guy is the body content. And the body content, all it is just a bunch of HTML markup. So they're actually storing the HTML markup within the XML file itself. So I could, I guess, process the data by having the entire XML or XHTML schema available to me, in which case I have to go say, okay, this is the table body, here's the TR, TD, very, very cumbersome, and would take you forever to be able to deal with data like that. So what would be beneficial is to make use of this inner XML node. So depending on where you're at from the particular node in the tree, you'll get this inner XML node, which you can just use as a text node, in which case you get all the XML unparsed. So here you can see that we've taken the title from upper in the tree, and we're using the HTML content directly from inner XML under the body content, and I can then preview the data. I have my title here. If I hover my mouse over, you should see, long enough, you should see the title, and under HTML content, you should see, if you were to look closely enough, there's a bunch of HTML formatting within that blob of text there. So this is just a kind of an aside, kind of a handy tip if you're dealing with XML data. Okay. So those are the text parsers. Again, you can parse and build hierarchical structures using these entities, or components. So let's take a look at some common scenarios that you might run into when you're dealing with hierarchical data, and those would be creating hierarchies from multiple flat sources, flattening hierarchies, writing to relational tables, and transforming one hierarchy to another. So let's take a look at that in the product. And then so let's say, for example, we want to flatten a hierarchy. So let's go back to our, flattening hierarchies is this one. So here's our XML file, and we have a hierarchical format such as this, and here we have our one-to-one relationship. So here you can see that we have a flat structure on the right, and we've gone ahead and mapped it. So to flatten the hierarchy, it was just as simple as being able to map from further down in the node into this flat structure. Again, if this were a collection node, such as that we saw in this case, you'll have to make use of those flower transformations in order to dig into the collection node to get the appropriate nodes. So flattening hierarchies is probably the easiest thing, and you probably, when flattening hierarchies, you probably have a situation where you might have something like this, right? So you might have an XML file, or let's say a database model. So let's go to this one here. So let's say you have multiple tables, in which case you need to write into. So let's say I have either an XML, it doesn't matter what the hierarchy is, once it's in Centerprise, all hierarchies are the same. But let's say that I need to write into my orders table. I might flatten the hierarchy so it's like this. Order item and then product. So this is one example of flattening the hierarchy, and it's more specifically the case of where you're writing to relational tables. So let's take a look at this example. So here I have my XML source. In this case, it's a bunch of order information. I have 3 orders, and in those 3 orders, I have some shipping address, billing address, customer, and of course order items. And what I want to do is I want to deposit this hierarchical information into my 3 target flat target databases, but they're all related. I have my order item, and my customer table. So typically, when you have a relational, explicit relationship between these 3 tables, you're going to make use of, let's say, some generated key somewhere. So in this case, I'm making use of a dynamic lookup. So what the dynamic lookup all is doing is it's looking up this exact same table. In this case, we're looking up the order table. If we find the order based on some lookup logic, we're going to retrieve the order ID. If not, we're going to create a new one, and we're going to use the same order ID throughout in multiple tables, and so on and so forth. We're going to do the same thing for the order item relationship from the order item and the customer. In this case, we're making use of a simple transformation here. But the point being is that we can write to all 3 tables, all with the same order ID, all with generated order items ID, so that we get these database tables all writing in harmony and maintaining preferential integrity. So the last piece of advice that I'm going to give you when you need to do that is that you need to make sure that you use the constraint-based write on all 3 tables, or n number of tables that you're writing to. And this will ensure that when you're writing to the tables, the order, that it writes in the correct order, and it writes in a single transaction so that you're not left with orphan records in the table. So this is the example of taking in the hierarchical structure, flattening it out, and writing to disparate database tables, and making sure that you're maintaining the hierarchy in database relational tables, I should say. So another common usage scenario is going the other way, in which case you are creating a hierarchy. So in this case, we are taking our order, our line item table, and our product table, and we're going to, let's say, build an XML file, for example, or an EDI file. So I might take the XML destination file, create my, point to my XSD, data sources, XML. Sure, go ahead and save. We're not actually going to write it. Schema location should be in the same place. Root is the root. Click OK. So I want to write into something that looks like this. But what I'm going to do is make use of a component called tree joins. So the tree join component is one of those supplemental transformations that we kind of glossed over, but it is very, very useful in dealing with creating trees, or even dealing with intermediate trees, and it works the same exact way as the join transformation for the flat world. So here we can see at the very bottom we have a join, and then we have the tree join. So the tree join, what it does is you have a hierarchy. In this case, I have my order hierarchy and I have my order item hierarchy. And what I want to do is I want to take this, because if you were to look at it representationally, it would look like this. You have your parent table and your child table, and I want to represent that into a tree. So to do that, I have to know that when the order item matches this order item, I know in what node to stick it under. So to do that, we go to the properties screen and we join by fields here. So we say, well, left field order ID is equal to the right field order ID. And in this case, left and right is kind of a holdover from database terms. What this should be is outer node, and inner node is what it should be. And by the way, you can also do this in the database if you're looking for high performance joins. But in this case, we don't have very many records. We can leave it as is. So now that I have these two in the correct structure, I can just keep joining, and in which case I'm joining and creating a more complicated hierarchy for me to map into. So here I have my product under order item. If I wanted to introduce customers, I can do so, and then finally map into my target. And if this looks familiar, this is exactly what we did in our subflow. So here's all we did was we created a subflow, and for more information on subflows, I invite you to look at our other videos. But here you can see that's exactly what we did. We've taken all the entities, database entities, created tree joins with them, and got a bushier and bushier tree until we've ended up with the structure here at the very end here. So here we have line items, products, and customers. And these are all ready for me to use in some other downstream hierarchical format. So the last common scenario would be transforming hierarchies. So this might be from, let's say, for example, going from one hierarchy to another. So in this case, what we're doing is we're taking our EDI file and we're going to convert that to an XML file. So whenever you do something like this, undoubtedly it's going to be slightly more complicated. Then you're going to have a lot of lookups. Let's say, for example, we're translating product codes from one system to another. You're going to have to be getting different nodes and flattening them out in order to write into the proper tree in order before we get to a hierarchical destination. But it is very possible and probably very unique in the world to Centerprise to be able to do something like this. So whether you're going from XML to EDI, EDI to XML, hierarchical database to XML, vice versa, all those scenarios can be handled in Centerprise and all in one map and all with a very specific tool set with a data flow. So in this demonstration, I won't be talking about other things such as workflow, scheduling, servers, and all that. We have other webinars for that. At this point, I think I've kind of covered everything I wanted to cover as far as hierarchical data and how to deal with it in Centerprise. At this point, I'd like to take any questions that you have for me. So let's take a look here. Okay, so I have hundreds of XMLs located on a server. I need to be able to extract all available XMLs from that directory and create a source location of all conjoined XML to begin my data flow. So what sounds like you mean is that you have a bunch of XML files and you need to create a single target based on a bunch of those XML. So what you can do is we have a, let's take a look here, we have a, and by the way, if I happen to go over, feel free to stay on. I'll probably be going over for a few minutes here. So, so in the sources here, you'll find the, what is this, the file system entry source. In the file system entry source, you can point to your directory. So let's say that I'm pointing to cusdemos, and I want to point to .xml files, and click OK. And now I can iterate through these and get the file path. And once I have the file path, I can actually make use of, I don't know if this one has it or not. If it doesn't, we can use the, so let's just find test.xsd, transformation. No, this one does not have it. So for this case, we'll have to use the workflow. So the way you would do it is you would go create a workflow, which I kind of hasn't showed yet, but we'll just go ahead and do the same thing. File system entry source, share, click OK, XML, click OK, and here we got to just, the only thing we got to do is change it as an iterator loop. And now let's take one of our existing data flows. Let's take flow using XML, and I would then take my input as the XML file source, take the full path, and boom, I'm done. So now this is just an extra component that kind of will loop through that file system and then process each XML file individually. So hopefully I answered your question there. Okay. So this is the kind of the workflow method of it. Another method to do that would be in the data flow would be to use one of the functions here. And under the function transformations, you'll find some file functions. and you can use the read file text. So in read file text, if you do so I'm giving you two different ways to do this. So we can say take the full path as a file path, and the output will be just a bunch of text. Well, lo and behold, we have the XML parser, in which case you can send that text to the parser, give it your schema of that XML file, and then be able to process as I showed you in the previous example. Okay, any other questions? Okay, let's see here. We have, do you support HIPAA transactions? Okay, so this is in the context of EDI. Yes, we do support HIPAA transactions. If we take a look here at the source here, we can see that this is an X12-850. We support all X12 messages with support for EDIFACT coming shortly. But all X12, including all HIPAA transactions, are supported with our with Centerprise and other products. Okay. Other question, can you process messages in real time? So yeah, I believe I discussed that in one of the slides here. We do, right now I showed you everything I showed you was kind of batch processing, but when you're talking about, especially in the concept of web services, all of these are typically done in real time, and you'll typically involve components mixing both data flow and workflow, such as you need to monitor a message queue, you need to write to a message queue, you need to send a message to a web service. And that the only difference between the batch and the real-time mode, the hierarchical processing does not change. The only difference is that you might be dealing with transactions in that case, such as in the case where we're talking about writing to relational tables. All three of these will be done in each individual record will be its own transaction, as opposed to, let's say, writing everything in one transaction. So, but as far as the difference, there is no difference between how you're doing the mapping. There are some slight rule changes, but we won't get into that in this webinar. But as far as dealing with the hierarchical information itself, it is all exactly the same. Okay, then another question, do we need to use XLT to perform these transformations? No, no, and that's kind of the point of what I was showing you with a lot of this webinar, is that you do not need to do that. So in a lot of other ETL tools, if you were presented with XML data such as this, what you would have to do is either run some sort of XSLT to process it to get it into a flat format, in which case you're looking for individual nodes, or maybe you have some other script that you have to run ahead of time. With Centerprise, you don't have to do any of that. You can just point to the file, point to your structure, and just start mapping to it, mapping from it, or creating a structure. So again, this is kind of something very unique to Centerprise, very powerful. We hopefully find that you'll find it easy to use as well. Okay, I think we're kind of out of time for now. If, any other questions will be answered on the website. You can look for this recording of this demonstration in the future, probably about a couple days to a week from now. Like we kind of went over the question and answers. Any other questions and answers, you can contact us at astera.com. You can call us at the number provided here. You can email us at sales@astera.com. You can talk to Manira Lalani. She's our head sales account manager. And you can email her directly at manira.lalani@astera.com. You can also submit questions on our forum, which will be forum.astera.com. And that is the end of this demonstration, and I thank you for joining us. We look forward to speaking with you again. We'll probably have another webinar in about a month. Okay, thank you for joining this demonstration.